Welcome to the quick start for Advantech's EdgeLink products. So which part numbers are we talking about under EdgeLink? These are the hardware bundles that you need to order so that they are prepared with EdgeLink from Advantech. The prefix ESRP is how you delineate between a normal bare product and the bundles. So here's the first three products under this category, which is the ESRP Atom 6700 series. They have various inputs and outputs. They have two Ethernet ports on them that act as independent network interfaces, and two serial ports and a micro SD slot for logging. If you're holding one in your hands, you can look for this label ESRP PCS Atom 67 and then the part number. These are different than the bare Atom 6700 modules, which have Node Red running on them. Then we have these two ECU products, which are just basically gateways. They have various serial port options. They also have the two Ethernet ports and a micro SD capability for data logging. Here's the second of those two, which you can see is a little larger and has 4 COM ports versus the 2-port model. This is the more diverse I/O option, the Atom 3600 model, with built-in I/O and then the ability to take in some small modules. It uses a SD card and has 2 serial ports as well. And finally, the slightly more powerful Y710 product with a couple of digital ins and digital outs on the top, 2 gigabit Ethernet ports, 2 serial ports, and a micro SD slot for data logging again. So EdgeLink consists of basically 2 pieces. At the bottom is the runtime, which is the preloaded part on all the preceding hardware products we just discussed. All of those, the Atom, the ECU, the Ys, those are all running Linux, and then with our special runtime application running on them. That's where all of the field devices are connected, the data acquisition, data logging happens, and where cloud connections are eventually done. To configure the runtime, you need the top part, which is the EdgeLink Studio product. Runs in Windows. So for this demonstration, I'm taking out one ESRP Atom 6717. I have the 2 Ethernet ports connected to what would be in a real-world scenario the IT or Internet for LAN 2, and then OT or Operational Technology Network, basically what you're trying to collect sensor-wise, and also this is where the EdgeLink Studio PC is connected. Here are some of the preconditions before running this demo. I'm not going to run through them point by point. You can pause here and read these for yourself, but most importantly is actually the middle one, which is you need to match up your EdgeLink Studio version with the runtime version. So here's a conceptual overview of what's going on in the runtime. Down at the bottom you have all of your various drivers, or some of these could be direct I/O if you're talking about an Atom 6700 or a 3600. So those drivers will obtain or collect the data from those various remote devices. And then in the middle layer you have the process capacity for this runtime, which is where you do your data logging if you want to create an event based on some condition. You need to do scaling. That's what we'll call process data. And at the top we have the push, which is how you get your data out to the cloud, MQTT, presented on Modbus, OPC UA, those various things. Throughout the remainder of this demonstration, I will endeavor to put these colored indications up in the upper right hand corner to indicate what activity we're actually performing as we go through these live demonstrations. So we'll start off with the EdgeLink Studio application. Here under the tree on the left, I'll point your attention to the 2 icons where we start off under Project Configuration and then the Online Device Monitor. So we'll start off searching for available devices on the network. And then with the connected device we will launch the console. The default username is root with no password. We'll type the command IP address to look at our current IP addresses. This is the IP address that we're connected to. I'm going to copy the MAC address here and save it for a little later when we'll use it as a unique ID when we set up our MQTT connection. We'll switch back over to project configuration and create a new project. And within this new project we will add a device. Select our device from the wizard. The default IP address is of course okay for this demonstration. We need to set the time zone. This is important so that if we had one of our various cloud connections that is dependent on an exact matching synchronized timestamp, that we're in that time zone. Once you click apply, you'll see the rest of the tree fill in. We'll take a quick look at the network settings. There are quite a few options for networking in the EdgeLink products. LAN 1, LAN 2, those are default. Those are available in all the 7 products that I've listed so far. There are other options, however, you would probably have to add expansion either through USB or cards to get those. So under LAN 1, LAN 2, this would be the place where you would set your static address if so required. Once you apply the project to the device, it takes on that setting. So whereas this is the default and the one that I've hard-coded into this project, if you applied a new address to say LAN 1, LAN 2, those would overwrite whatever the module currently has set up in it. So you can click apply. So let's work through the tree here on the left under project configuration, starting at the top. Data center, this is going to be the category that represents all of the collection of data, or that lowest level that we saw on that earlier slide. As this is an Atom 6717, it does have onboard I/O. So here under board I/O, you can choose all of the range codes or the minimum and maximum of the inputs that you're using. Here underneath I/O tag, you'll see the tags that represent each of the data points or channels coming from this device. So I don't actually have to create them. All of that's automatic. I will create a sim or simulation device here that's just reading back information from the PC that I'm currently doing this demonstration with. We'll use Modicon. Enter the IP address of the computer. Standard port 502 for Modbus. Some other settings I don't need to adjust. And then it automatically brings up a pane for the I/O tags of this device. I can expand the tree. So here's the tree. You can add more devices. You can add them to serial if you had serial devices. So I'll add a new tag. This will be a holding register tag. An unsigned 16-bit integer. All of the various options for dealing with integers, offsets, and whatnot. Over here on the right, you can perform scaling, so this would fall into the process category of what EdgeLink can do. Hit OK for that. So now we have the name of this tag, sim:4x1. Below these, you have the system tag list. These tags are also automatically created and basically represent internal variables the runtime is presenting for you to use. Uptime, current time, various mobile information, some information on the storage card capacity. Obviously, these mobile tags would only be filled in if you had that kind of a card installed in the device. Below system tag we have calculation tag. So these are a more user modifiable version of variables that you create. So I'll create one that basically rolls over every 5 minutes. I'll use the from so now all tags are equal in this sense. So whether I use the 5-minute tag, the sim:4x1 or AI1, they're all equally insertable into any of the subsequent stages that we'll go through here. So now we're into the processing category of EdgeLink's capacity. Here under data logger, I can enable. So this device, this Atom 6717, has a micro SD formatted FAT32 inserted before I turned it on, and that's where it's a database where this database is going to be stored, and then I can enable each of the data points in turn. And apply. Under service are the various services running on EdgeLink. These don't really fall under collect or quite process or even quite push. They represent all of those things. You could have a client read and write into EdgeLink. You could have something purely pull out of EdgeLink. So here's port 502 now. So this is port 502 of the Atom, not of my computer in this sense. And the same deal, we can fill in the same exact information that we did for the data logger. Apply. I'm not going to actually fire up a copy of, say, ModScan or the Atom utility to pull this Modbus server. It's just a demonstration of that it is there. OPC UA, I will actually, at the very end of this video, show a client quickly joining to the available port. And this works just like Modbus. You can add the same tags, make them available for consumption by an OPC UA client. Below service we have Event Manager, so you can set up, once you've set up an SNMP server, which is done under system, you can have the EdgeLink runtime monitor for out of range or quality bad. If your device, if it was say a serial device and the serial port suddenly couldn't pull that device, you could have it send you an email or write another tag if you needed some kind of small logic capacity there. If you need something that's way more logic oriented, the Atom 6717, the ECU series, and the Atom 3600 all have this KW soft PLC characteristic you can run on them. It's not enabled by default, and you don't actually write your ladder logic or structured text flowchart. You need another piece of software. You can download that from Advantech.com. So within EdgeLink, all you're going to do is check that and apply, and then it'll run from there on out. There's not any more settings or monitoring here within EdgeLink for KW. So we'll move down to the cloud. So cloud is the push capacity of EdgeLink. All the various services that it supports. Simple MQTT, the one we'll use here, represents pretty much the most generic version of it. So you enable it, fill in the broker URL. We will we'll speed this up a bit. So let's push this every 10 seconds. I'm going to turn off data resume. This is a nice feature of EdgeLink where if you have a broker that's backed by a database that, say, your connection drops out between this, the EdgeLink representing a publishing client. So if the connection drops out between the module, the runtime, and the broker, once the connection's resumed and regarded as stable, EdgeLink will begin to push out the data logged values that were stored up in that intervening period. The broker I'm using here at the top, broker MQTT dashboard.com, doesn't have any kind of backup database. So in that case, the extra samples would just be lost or unable to be processed. So we don't want that. And then I will give it a custom topic name based on the MAC address of this device. And then we also need to fill in the various tags that we want to be pushed out to. So the last step is to save the project, and then you need to, you'll notice here this is grayed out because it doesn't know where you are in the tree. So click back on your IP address here of your device, and then download, and wait a small amount of time for it to compile. If you were to change the IP address of your device within the project so that this gets altered, this is the last thing you'll see. You won't get this restart success indication. Restart success is because my IP addresses all match, and in which case you just have to close out of this dialog. But I got restart success because I can continue to talk to this device. So we'll close out of the dialog for the download. So like I said, I've got this Modbus simulator running in the background. I've got my firewall adjusted in Windows so that these packets are coming through. You can see every time there's a request coming from the EdgeLink device that it comes through. I can also edit the simulated value up there in the upper left. I'll just leave that running. So let's hop back over and monitor the device or see what's going on. Just right click, monitor. So for this one, a hard-coded admin username. Password is 8 zeros. There we go. So on the tree on the left here, we have information about the module itself. You can view online live values. I can adjust them here with my multimeter process meter. Here's the tags. So system tags come first. Then IO tags. So these are both, IO tags hold both the onboard board IO and also the tags. Let me adjust that one more time. So there you can see that move up. So they hold both the board IO tags and the tags from that simulated value here that it's reading over Modbus TCP. Under System Info, you'll see the various messages that it puts out as it tries to connect to brokers or tries to connect to serial devices and that sort of thing. So the next stage of this demonstration will be to show off the data logger function of EdgeLink. So here we'll query for 5 minute, the 5-minute tag, and you can see every 300 seconds it cycles up and then down. We can do the same thing. We can query the data logger for the analog input data. So that's my process meter generating a voltage difference. And then here at the bottom you can actually save it as a CSV, export it to your computer's hard drive. Here's the simulated data from that Modbus device, which is really just my PC. So let's hop into MQTT Explorer and look at the last stage of the push. So the EdgeLink publishing client pushes out to the public broker, and then now we'll subscribe using MQTT Explorer to the same topics. Here I've altered the topic filter so that we're just getting Advantech's topics and not the entire brokers, because this is a public broker. So connect. Wait a few seconds for a new fresh publish from the client. So in the upper left hand side you'll see that the MAC address of the device and then the payload and the various JSON values that are embedded in there. So that little jaggedy graph icon created those two left-hand graphs. I'm going to speed up the video a little bit here just so you can see these values flow in, because right now we have the publishing set to 10-second intervals. And my process meter is generating new data. That's the middle wavy line. And here at the very end you'll see the fall off as on the left hand chart where the 5-minute tag resets back down to 0. So the very last thing to demonstrate today is just a OPC UA client joining the onboard server. I've already got a project created for this OPC client, and that pretty much simply consists of this endpoint URL, IP address of the Atom device, and then that port address. You can copy and paste that out of EdgeLink. Once you connect, it automatically scans for the available tags. You can drag them over to this data access view pane. My process meter is still generating a small voltage up and down. And then I have the digital input shorted to D ground, and you can see it toggles on and off as I move that wire. So that concludes this demonstration, this quick start for Advantech EdgeLink.